Okay, this is the third locus lesson. So put your heading just like I have it on your loose leaf. Alright. Then the title is Locus Theorem 3, and it's called Equidistant from 2 points. So then you need to skip a line and write this down. The locus of points equidistant from 2 points, P and Q, is the perpendicular bisector of the line segment determined by the 2 points. Okay? So here's what we mean by that. This is what the picture looks like. If you have 2 points, say one's here, and this is P, and let's say one's over here, and this is Q. Think of all the points that are equidistant between P and Q, right? Now there's one directly in the middle, we know that. But where are all the other points that are the same distance from P and Q? Well, if I go up a little bit, isn't that point still the same distance from P and Q? It's at a little bit of an angle, right? But it's at the same distance. I can also go down a little bit, right? And I can keep going up, in fact, and all of these points are the same distance from P as they are to Q. And I can do the same thing going down. So what you should start to notice is that all the points that are equidistant from P and Q is a line that's directly between P and Q. And that line, it turns out, is the perpendicular bisector. So let's draw in that line first. Let's draw it dashed. It's the perpendicular bisector of the segment that joins P and Q. So not only is it perpendicular, right, which means it forms all right 90-degree angles, it also bisects the segment between P and Q. So all of the points on this line are the same distance to P as they are to Q. And if you needed to prove that to yourself, you could just measure, put a point on the line and measure it, and you'd see that it's the same distance from P as it is to Q. Okay? So the locus of points equidistant from 2 points is a line that goes down the middle of them like that. Okay? So you could skip a line and put consider. This is one of those consider problems, okay, or questions. And it says you are playing a game of paintball, so you're going to write this down. 2 of your friends are hiding behind trees that are 10 feet apart. Where could you possibly stand so that your firing distance to each friend is exactly the same length? Okay? So, this is just to try to help you visualize the locus theorem in a real life scenario, right? Say you have a point over here. This is the tree with your first friend, and then you have a point over here, and this is another tree, and this is your second friend. Okay, so where could you stand so that you could shoot them the same distance? Alright, and let's say these trees, it says they're 10 feet apart, but that really doesn't make a difference, right? The total distance is 10, so the easiest place you could stand, or the most obvious, is directly in between them. And then each one of these distances would be 5 feet, right? But like we said before, you could also stand here, or here, or here, or here, or anywhere along the perpendicular bisector of that segment. You would be at the same firing distance, right, between your 2 friends. So this is just another demonstration of this locus theorem using more of a real life scenario to try to help you understand it a little better. It's not complicated. All it says is that the points that are equidistant from 2 points are all the points on a line down the middle of those 2 points. Alright? So, turn this sheet over. and you write down the answer to this problem, or if you already went on the back, just write it underneath. So at first it may seem that there is only one spot to stand where you are the same distance from both of your friends, the spot being directly between your friends, 5 feet from each friend. But as the diagram shows, there are actually many spots that will position you exactly the same distance from both friends. Notice the formation of the isosceles triangles where the congruent or equal sides represent the distances to each friend. Let's take a look at that. Back on the front side. Right? Say you were standing right here where I made that dot. Look what happens. This distance right here is the same as this distance right here. And do you see what you formed? You formed an isosceles triangle, right? Or let's say you stood over here. No matter where you stand, what happens is you form an isosceles triangle. And in this, if you stood over here now, this distance would be equal to this distance, whatever it is, okay? And so that happens for anywhere we stand here. So let's do one more. If we stand up here, then this distance would be the same as this distance. So all the points on this line are equidistant from those 2 points. Okay? Let's go back to the other side. We have one more statement to write down. Okay? So the different positions where you might stand form the locus of points equidistant, which means equally distant, from your 2 friends. This line is the perpendicular bisector of the segment joining your 2 friends. Hopefully by now you realize that understanding perpendicular and bisector is important, because this is probably the 100th time we've seen those 2 words together this year. So you should definitely know what that is by now. Alright. Now at the bottom of the page, let's do example 1. The locus of points equidistant from 2 fixed points is, well, this is what we've been talking about. It's a straight line. Right? If you have, and you have to draw this diagram. If you have 2 points, then the locus of points that's equidistant from those 2 points is, if these are 4 centimeters apart, it's directly in the middle, and it's perpendicular. So I'm going to draw a perpendicular line where I think it is. It's going to be close enough. So there you have it. Okay? Those are all the points that are equidistant from those 2 points. It's a straight line. Now on your graph paper, okay, on the front of your graph paper, I want you to put your heading at the top. Okay, just like you've been doing. Alright, and I want you to write down example 2 right below that. Okay. And my paper looks a little differently from yours, but you're just going to use your graph paper. Alright. So example 2, what is the equation of the locus of points equidistant from the points 4, 2 and negative 2, 2? So on our axes here, let's draw an X and Y coordinate axis. I'm going to use this right here as my center. So I'm going to go 6 in each direction. Okay. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I'm going to go 6 up and 6 down also. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. This is my Y. This is my x. Okay? So 4, 2, 1, 2, 3, 4, 1, 2. And then negative 2, 2, negative 1, negative 2, 1, 2 is right here. So what's the equation of the locus of points equidistant from those 2 points? Well, it's the line that goes directly down the middle of them. These are 1, 2, 3, 4, 5, 6 apart. So at 3 over, 1, 2, 3, that's where our line goes down. Let's make it dashed. Okay, and the equation of that line is x equals 1. It goes through 1 on the x-axis. So in here, over in the space, put x equals 1 and circle it because it wants the equation. Okay, let's look at number 3. There are 2 buoys in a lake. A scuba diver swims so that he is always equidistant from both buoys. Describe his path. Well, let's draw first a picture of what this looks like. Let's say this dot is buoy 1, and this dot over here is buoy 2. So the swimmer, or the scuba diver, swims directly in between them. So the scuba diver is essentially swimming along this line. So let's put, whoop, spelled that wrong. Let's put scuba diver along this, scuba diver right along that line. Okay? That would make sure that he stays directly between those 2 buoys. Alright? So that's our picture. Now let's write a description of what's happening in this picture. So the path of the scuba diver will be a straight line which is perpendicular to a line containing the 2 buoys and halfway between the 2 buoys. So let's also draw the line between the 2 buoys. So it's exactly halfway. We can demonstrate that by putting a hash mark on each side. And it's perpendicular, so let's put right angle marks. Okay? So that's how we describe in words what's going on. Now let's turn this over. Look at example 4. You're just going to write this on the top of your graph paper. 2 houses are 180 feet apart. The underground electrical cable used to service the houses is to be placed such that the distance from any point on the cable to each home is always the same distance. Describe where the cable should be placed. So this is the same type of problem over and over again, right? So let's say this is house A, and this is house B. And let's say the distance between them, I'm going to draw a light line connecting them. That distance is 180 feet, right? So there's an underground electrical cable used to service the houses, and it has to be the same distance from those 2 houses. So that means it has to be running directly up and down in between the 2 houses. So it's the same type of problem. It's the locus of points. These form a right angle, all 4 corners. So if the whole distance is 108, then each side is going to be 90 feet, right? And that's it. So then we have to write a description, though. It says describe, so we have to describe it in words. So here's what you would write. And you have to write this. The electrical cable should be placed perpendicular to a line segment connecting the 2 houses and crossing that line segment at a point 90 feet from each house. In this way, each point on the cable will be the same distance from each house. Okay? And then we do the last problem at the bottom of your graph paper. Example 5. What is the equation of the locus of points equidistant from the points -1, -3 and -1, 4? So, let's plot. Well, let's draw our axes first. I'm going to use this as the center. I'm going to go 6 again in each direction. Okay, this is X, this is Y. -1, -3, -1, 4. There's 1, 2, 3, 4, 5, 6, 7. There's 7 between that, and 7 divided by 2 is 3.5. So we have to go 3.5. So 1, 2, 3.5. That's right in the middle of that line. Just like that, okay? And the equation would be y equals, because it's a horizontal line, so that's a y equals line, and it goes through 1/2 on the y-axis, right? That's between 0 and 1 directly in the middle. That's 1/2. So we can say 0.5. So the equation is y equals 0.5. We could also write or y equals 1/2, okay? Either way you want to write it, with the decimal or the fraction is fine. And so let's just put our there's 2 sheets. So in the top right of the first one, put 1 out of 2, and in the top right of the second one, put 2 out of 2. Alright, and that is the end of lesson 3 on locuses.